Yeah, everyone. Welcome back to yet another video. Today we're going to have a look at applications of anti-differentiation. And we're just going to do one question, one worded question today, just to have a look at the types of questions that you could get in the exam or in a SAC for math methods, and sort of how we sort of go through it. So let's have a look at this. I picked this question because it's pretty wordy, and so it's a bit of sort of need to interpret some information from there. So let's get going with this now. So let's have a look. So a chemical factory has permission from the Environmental Protection Authority to release particular toxic gases into the atmosphere for a period of 20 seconds, no more than once every 3 hours. Okay, so they're releasing, so once every 3 hours, they get 20 seconds to release some gas into the atmosphere. To be honest with you, not much of this is important information. Like none of this is important. And it's probably until it gets to here, there where it says, okay, so there's 20 seconds every 3 hours that there's some gas release. So none of that other stuff is really important. This maintains safe levels of gas. So again, I don't care. I mean, we do care. I mean, we care about the environment. But as far as our question goes here, that doesn't add anything to the maths of here. It just maintains safe levels of gas in the atmosphere. Great. This rate of emission is given by, so here is my rate. And so I read this and I go dV dt. Okay, so I'm wondering to myself, what's V and what's T? If I look at the units here, and sorry to sort of talk about a bunch of things. If I look at the units there, centimeters cubed, so V is obviously the volume, because remember dV dt, dV over dt, that tells you if you've got centimeters cubed over seconds or per seconds, that means centimeters cubed is relating to the V. So that's obviously volume, centimeters cubed, and S is the measurement of seconds of time. So I'm guessing that that's what that means. So I know it's going to tell me that in a second, but it's good to be able to read these things without being told, so that you know what's going on and you can guess what's happening in most situations. So it's given me the rate that this volume of bad gas is coming out of their pipes, their stacks. So it's saying where T is between 0 and 20, and it's between 0 and 20 because it's only happening over a period of 20 seconds. So, and then it stops. V centimeters cubed is the volume of toxic gases released over T seconds. So that's what we guessed anyway. So don't even need to be told that. We could figure it out from the units given right there. Okay. Calculate the total volume of toxic gases released during a 20-second release period. Okay. Great. And so let's have a look at this, right? So we've got I'm just going to write it down here. I'm just going to write this. So we've got dV. I just like writing down the formula first. So dV dt is 20t squared minus t cubed. All right. And we want the total volume, and we know that V is the total volume. And so all I need to do is to find the antiderivative of this function, and that will give me my volume. So let's have a look at this. So let's do that. So V is equal to the antiderivative of 20t minus t cubed. Did I miss a squared? I did. 20t squared minus t cubed. Don't forget your dt. I'm just going to go across so I can still see the come down a little bit. And so here we go. So that's 20 t. That will go up to the power of 3. We increase it by power by 3, and then we divide by 3. So that's the first part done. Minus t, that 3 will go up to a 4, and then we divide by 4. A little bit messy there, a massive 20 sitting over there. But that's the antiderivative, and then we need to plus c. There'll be some constant term when we find the antiderivative. So there is my volume. Okay, now, given that I've got that, I'm just going to put a box around it. That's my volume. Okay, now I need to find the total volume of toxic gases released during a 20-second release period. So all I need to do is substitute T is equal to 20 into this, and that'll be my answer, all right? But I don't know C. Okay, so I need to find a way, find some condition that will help me to be able to find C. Do I know anything else? Right, so we're not told anything in this question. It doesn't say the volume of gas after 5 seconds is this. It hasn't actually given us any sort of condition that will help us. But if we actually interpret it and look in this situation and go, well, do we know what's happening? So V is the volume released over T seconds. Do we know the volume released after 0 seconds? If you think about that, well, it hasn't actually started. Looking back to the question, it hasn't started before that time. Before that period of 20 seconds, there's been zero gases released. Okay, so what we know, and we've read it just by interpreting from the question, we know that the volume after 0 seconds is equal to zero. The initial volume of gases released is equal to zero. And so we can use that fact to sub into our formula. And so therefore, also that. So I'm just going to rewrite this. So Vt is equal to 20 thirds T cubed minus 1 quarter T4 plus C. I'm just rewriting that just so that it's nice and clear here. And so then I'm going to sub in V naught is equal to naught. So therefore, 20 thirds times 0 cubed minus, you're probably sitting there going, why is he bothering doing all this? It's just obvious what the answer is. That's okay. I'm just going to do it to make sure everyone can see. Plus C, and that's all equal to 0. And obviously, you're sitting there going, yep, that's 0. That's 0. So therefore, C is equal to 0. Okay? Therefore, C is equal to 0. That was a whole lot of work for not finding out much, but we've confirmed the exact formula. And so the exact formula for V, therefore Vt, I shouldn't be doing a squiggle on that V, it looks more like velocity there, is equal to 20 on 3 T cubed minus 1 quarter T4. So that's the final volume. That's it, as in the equation for the volume. The question wants 20. Oh, geez, that's going to be a big number. Might need a calculator. We'll see how we go. So V20 is equal to 20 on 3 times 20 to the power of 3. Gosh, can I do that? Yeah, I think I can. Minus 1 quarter 20 to the power of 4. Okay, let's try to do this by hand. So here we go. 20 thirds. So 2 cubed is equal to 8, and then the 0, so it's going to be 8 with 3 zeros, so 8,000. Just check that I've got that right. 20, 400, 8,000. Yep. Take away 1 quarter, 20 to the power 4. 2 to the power 4 is 16, and so it'll be 16, and that 0, because what I'm just doing, I'm just going 2 times 10 to the power 4 is equal to 2 to the power 4 times 10 to the power 4. That's essentially what I'm doing in my head. And so that'll be 16 with 4 zeros. 1, 2, 3, 4. Can I keep doing it in my head? I'll keep going. And so that's equal to 16 with 4 zeros. 1, 2, 3, 4 over 3. I'm going to run into a place where I'm not going to want to do these fractions. A quarter of 16, that's actually nice. So that's 4 with 4 zeros. 1, 2, 3, 4. Is that nice? I'll just put them both over 3. I'm just going to do some quick. I'm going to put that over 3. So I'm going to make that 12. Okay. And so then that's equal to 16 with 4 zeros minus 12 with 4 zeros. So that's equal to, I can do this. So 4 with 4 zeros. Is that right? Over 3. And I might leave my answer as that because that is exact, okay? Because the question didn't say, it says calculate the total volume of toxic gases released during a 20-second release period. It doesn't say to the nearest, centimeter cubed or anything. So I'm going to give my answer as exact, and I'm going to leave it like that. Hopefully all my fraction work has been correct. Now, so that's my answer. It's volume. What is volume measured in? Volume is measured in centimeters cubed, and so I just need to make sure I answer the question equals centimeters cubed, and there we go. Hope that all made sense, and I hope I didn't make any fraction errors there, or power errors for that matter, and hopefully that is all good. I'll see you in the next video.